Alright, we are starting chapter 8 here, so all of chapter 8 is just one note section, and it's one homework assignment, because we kind of really pick and choose what we want to do in chapter 8, and so here's that video. Alright, 8.1 is Systems of Equations. So systems of equations, remember, like, if we graph them, they cross, and where they cross is the solution. If they're parallel lines, they never cross, which is inconsistent, and they're consistent and dependent if it's the same line, meaning there's many solutions, infinite amount of solutions. So this is two variable system. You know how like the elimination method, which is also known as the addition method, and then we have the substitution method. That is how we've been solving linear equations with two variables. Now we're going to solve systems with three variables, with three equations. So this is what they look like if you were to graph them. We don't graph them, thankfully, in this class, but you know, later on if you're in calculus, you will learn to graph these. So how it looks as a solution, this is how it would look graphically, which is pretty cool. Alright, let's solve this system. So with solving systems of three variables, I have a system. I know, you can laugh at me, it's okay. So the system I have, now if you are, you know, pretty good at systems of equations with lines, you might be able to tell, like, I don't need to use this method, but I came up with this method so you always know what to do, when to do it, okay? So I'm going to write some stuff out. It's not going to make any sense until we actually do it, so just bear with me. So my system is, you have three equations. Your first equation, you kind of just leave it your first. Then we take the first and the second equation, add them to get new 2. Take the first and the third to get new 3. We add new 2 and new 3. We solve, then we plug in. I promise it'll make sense when we actually start to do it. So 1, 2, 3, where are all these things coming from? From the equations themselves. This is equation 1, this is equation 2, this is equation 3. So we have our 1 equation, 2 equation, 3 equation. So first we need to find our new 2. So to find our new 2, we add 1 and 2. So the first equation is x minus 2y plus 3z equals 7. Our second equation is 2x plus y plus z equals 4, and we need to add these. So remember, for elimination method, also known as the addition method, we want to get one variable to cancel it out. So one of these variables needs to be the same sign, same number, but opposite sign. If you need a refresher on solving systems of equations, I do have videos from intermediate algebra. They're on my YouTube. So we're going to look at one of the variables and get rid of it. It doesn't matter. You can get rid of x, y, or z. For my notes and what I did, I want to get rid of y. So this is negative 2y. This is positive y. That means they're already opposite signs. I just need to make the coefficient, the number in front, the same. In order to do that, I'm going to multiply the bottom by 2. So I multiply everything by 2 on the bottom. I did nothing to the top, so I just rewrite it. And on the bottom, I have 2 times 2x is 4x. 2 times 2 times y is 2y. 2 times z is 2z. And 2 times 4 is 8. Alright, so now we're going to add them. We add the columns because you see what happens? When we add them, we have x plus 4x is 5x. Negative 2y plus 2y. That cancels it out. 3z plus 2z is 5z. And 7 plus 8, we get 15. This is our new 2. Now we need to find new 3. So new 3, we take equation 1 and equation 3. In new 2, we got rid of y. So in new 3, we need to get rid of y. Whatever you do in new 2, you need to replicate that for new 3. So since in new 2 there is no y, we need to do the same thing for new 3. We need to get rid of y. Luckily, they're already opposites. Minus plus 2y, 2y. So they're already opposites of each other. We don't need to do anything. So we have x plus negative 3x is negative 2x. The y's cancel. 3z minus 2z is positive 1z. And 7 minus 10 is negative 3. That is what we call our new 3. So with our new 3 and new 2, we're going to take those and add them together. So our new 2, we have 5x plus 5z equals 15. And then our new 3, we have negative 2x plus z equals negative 3. And we're going to add them. So we just do the same thing. We pick a variable and get rid of it. The variable I picked to get rid of was z. So this is 5z. This is regular z. So I'm going to multiply the bottom by negative 5. So 5x plus 5z equals 15. And then on the bottom we have negative 5 times negative 2x is positive 10x. Negative 5 times z is negative 5z. And negative 5 times negative 3 is positive 15. We're going to add these. The z's go bye-bye. So we have 10x and 5x is 15x. 15 and 15 is 30. Divide by 15, so we get x equals 2. Now that we have x is 2, we're going to plug this into one of the new 2's, our new 3's. So the one I chose it to plug into was the top one. Why? Because it's positive. That's the only reason why. So I'm going to take my top one, which is 5x plus 5z equals 15. I have x. I just found it. So I'm going to plug it in. We have 5x plus 5z equals 15, and the x we're plugging in is 2. So we simplify to get 10 plus 5z equals 15. I'm going to subtract 10 to both sides to get 5z equals 5. Divide by 5 to get z equals 1. We have 2 out of 3. We're just missing y. So now that you found 2 of them, we really use new 2 and new 3 the most. Now that we have 2 missing variables found, we're going to plug both of them into any of the original equations. So we're going to plug x and z into either original 1, original 2, or original 3. Keep in mind that we're missing y. So I'm going to use regular 2 because y, there's nothing in front of it. It makes my life easier. So using regular equation 2, so regular equation 2, we have 2x plus y plus z equals 4. We're going to plug in the values we found. So 2x plus y plus z equals 4. The x we found was positive 2. The z we found was positive 1. So 2 times 2 is 4. We combine like terms to get 4 plus 1, which is 5. Subtract 5 to both sides, and we get y equals negative 1. So our answer is 2, negative 1, 1. Because this is a point. If you were to graph these when you learn, and if you learn to graph these, this is where all 3 would intersect. We do this method the same every time, if you want to. If you can pick up and be like, I don't need to do all this, or like, I don't need to do new 1, new 2, new 3, all that, that's fine. This is just a method I came up with, so it takes out the guesswork. You know exactly what you need to do every single time. Alright, example 2. we're going to do the same thing. So we have our 1, 2, and 3. So we're going to take 1 and 2 to give us new 2. So our 1, we have x minus 3y plus 4z. My bad. So x minus 3y plus 4z equals 9. And 2, we have 2x plus y plus z equals 4. And then from here, we're going to look for a variable to get rid of. I chose to get rid of x because I want to. There's no other reason. I just chose to get rid of x. You can get rid of x, get rid of y, or get rid of z. So I'm going to multiply the top by negative 2. So we have negative 2 times x is negative 2x. Negative 2 times negative 3y is positive 6y. Negative 2 times 4z is negative 8z. And negative 2 times 9 is negative 18. And we did nothing to the bottom. Now we're going to add them. You notice our x's cancel out. Then we have 6y and y is 7y. Negative 8z and z is negative 7z. And negative 18 plus 4, we get 14. Negative 14. That is our new 2. Now we need to find new 3. So I'm going to rewrite 1 and 3. Sorry. I'm so sorry if you're wearing headphones and you heard that nasty cough. Alright, so in new 2, we got rid of x. So in new 3, we need to get rid of x. So x, they're already opposite signs, but this has a 2, so the top one needs a 2. So I'm going to multiply the top by 2. And so 2 times x is 2x. 2 times negative 3y is negative 6y. 2 times 4z is positive 8z. 2 times 9 is 12. 12. Sorry, 2 times, I was adding the bottom in my head. So easy to do that. 9 times 2 is 18. And we did nothing to the bottom. And now we're going to add. Our x's go away. So we have negative 6y plus 3y. That's negative 3y. 8z minus 3z is 5z. And 18 minus 10 is 8. That's our new 3. Now we take new 2, and we're going to add it to new 3. So new 2, we have 7y minus 7z equals negative 14. New 3, we have negative 3y plus 5z equals 8. Alright, we have to get rid of a variable. Doesn't matter, you can get rid of y, you can get rid of x, but for my notes, I got rid of y. So they're already opposite signs, but they need to be the same number. So in order to make them the same number, I just multiply them by each other. So times 3 times 7. So we have 3 times 7y is 21y minus 3 times 7z is negative 21z. And negative 14 times 3 is negative 42. On the bottom we have 7 times negative 3y is negative 21y. 7 times 5z is positive 35z. And 8 times 7 is 56. Now we add them. So our y's cancel. We have negative 21z plus 35z is 14z. Negative 42 plus 56 is 14. We divide by 14 to get z equals 1. So now that we found one of them, we're going to plug it back into either new 2 or new 3 and find y. I'm going to plug it in, doesn't matter. I'm going to choose the bottom one. I'm going to choose new 2 or new 3. You can plug it into anyone. So I have negative 3y plus 5z equals 8. So negative 3y plus 5z equals 8, and the z we're going to plug in now is 1. So we have negative 3, my bad, wrong color. Negative 3y plus 5 equals 8. I'm going to subtract 5 to both sides to get negative 3y equals 8 minus 3. 8 minus 5, which is 3. Divide by negative 3, so y equals negative 1. So we have 2 out of the 3 missing pieces. Now we're going to plug those 2 variables that we found, we're going to plug it into new 2 we're going to plug it into either 1, 2, or 3, it doesn't matter. So you notice we found y and z, that means we're missing x. I'm going to plug it into 1 because x is just x, so it's easier for me. So I'm going to plug what I found into equation 1. So equation 1, we have x minus 3y plus 4z equals 9. So we have x minus 3y plus 4z equals 9. The y we found was negative 1. The z we found was 1. We're going to simplify to get x plus 3 plus 4 equals 9. So x plus 7 equals 9. Subtract 7 to both sides, and we get x equals 2. So our answer is 2, negative 1, and 1. My bad, parentheses. Because that's x, y, z. The more you practice, it just becomes second nature. You gotta get the hang of it, okay? Alright, example 3. Do you notice anything weird about example 3? So look at the first one. First one has x, y, z. Second one has x, y, z. The third one, what's it missing? It's missing z. I'm not gonna even lie, when I do a pause, I feel like I'm Dora waiting for the kids to answer on the TV. It's great. I hope you know. I love that feeling. It's amazing. Alright, so you notice that the third one doesn't have a z? Since they don't all have a z, don't get rid of it. Just work with it. We are not allowed to get rid of z because not all of them have z. It just won't work out. So I need to find new 2 by adding 1 and 2. So 1, we have x minus y minus z equals 3. 2, we have 5x 5x plus 5y plus z equals 3. Now we need to get rid of something, but we can't touch the z. Do not touch that z because 3 does not have z. So we can either get rid of x or we can get rid of y. I chose to get rid of y because they're already opposite signs. I just need to multiply. So I'm going to multiply the top by 5. So we have 5x minus 5y minus 5z equals 15. And on the bottom, we didn't touch anything. We're going to cancel out our y's. So we have 10x minus 4z equals 18. That is our, that's 18. That is our new 2. So let's find our new 3. So to find new 3, we're going to take 1, which is x minus y minus z equals 3. We're going to take 3, which is 24x plus 16y equals 0. In new 2, we got rid of y. So for new 3, we must get rid of y. So I'm going to multiply the top by 16. So when we do, we have 16y, x, minus 16y minus 16z equals 16 times 3, which is 48. And on the bottom, we have 24x plus 16y equals 0. So we add them all up. We have 16x plus 24x is 40x minus 16z equals 48. That's our new 3. All right, now we need to take new 2 and add it to new 3. So new 2 new 3. All right, we can either get rid of x or we can get rid of y. It does not matter. Z. X or z. I got rid of z. So they're the same sign, but I can make 4 be 16. So I'm going to multiply by -4. Now it's -4 because they need to be opposite signs. So -4 times 10x is -40x, -4 times 4z is positive 16z, and -4 times 18 is -72. We didn't touch the bottom. Oh my gosh, what the heck is happening? What happened? Everything canceled out. So we have 0 equals -24. Does 0 equal -24? Nope. Never. Never ever. I can make 1 equal 2, but that's a whole different story. But nope, that is not true. No solution. We're big kids now, so no solution actually means inconsistent. That's what I'm going to be looking for the test. I'm going to ask, is this consistent? Is this consistent, or is this inconsistent? Meaning, does it have a solution, or is it no solution? All right, example 4. Let's go ahead and take a look at all of our variables. So we have x, y, z, x, y, z, x, y, z. Awesome. I don't need to be careful. I can get rid of whatever the heck I want. So let's number them. We got 1, 2, and 3. Now let's repeat the steps all over again. This is why I like this method, because it's just doing it over and over and over again. But sometimes we need that when things are a little complicated, right? All right, let's find our new 2. All right, our new 2, we're going to take 1, and we're going to take 2. Do you see anything that are the same but opposite signs already? I hope you do, because we can cancel those z's out. We don't have to do work. Awesome. So we have 3x minus 5y equals 8 plus 23, which is 31. And that's our new 2. All right, now we need to find new 3. So to find new 3, we take equation 1, equation 3, all right, in new 2, we got rid of z, so we need to get rid of z. They're already opposite signs, we just need to have them be the same number. So I'm going to multiply by 5. So we have 5x minus 10y minus 5z equals 40. And on the bottom, we didn't do anything. My bad. That's y. There we go. All right, we add. So we have 9x minus 15y equals 93. That's our new 3. So let's put these together. So we got our new 2. We got our new 3. And let's get rid of something. It does not matter what you get rid of. I chose to get rid of x. So I'm going to get rid of x by multiplying by -3. So we have negative 9x plus 15y equals negative 93. We didn't do anything to the bottom. What happened to everything? What's going to happen? Everything cancels. So we have 0 equals 0. Now that's true, right? 0 totally equals 0. That's like a real thing. Like, yeah, it's true. So we say the system is dependent. Now that's not our answer. This is where things get a little complicated. Alright, we're going to solve for a variable in any of the new equations. I'm picking new 2. You can pick new 3, it doesn't matter. I'm going to pick new 2. Alright, so we have new 2. And new 2 is 3x minus 5y equals 31. So pick a variable and solve. You can get x by itself, you can get y by itself, doesn't matter. I chose to get x by itself. So I'm going to add 5y to both sides. We have 3x equals 5y plus 31. And then I need to divide by 3. So we have 5y plus 31 over 3. After we find that, we're going to substitute what we found into 1, the original 1. So original 1 is x minus 2y minus z equals 8. And we always plug it into 1, the original 1. So we found x. That's what this is. Now I'm going to plug it in. Alright, from here, I'm going to solve for the variable that is most given. You see how there's multiple y's? That's what I'm going to solve for. So in order to do that, I need to get rid of this ugly fraction. I'm going to multiply everything by 3. What that does is it gets rid of the fraction. So now I'm working with 5y plus 31. So 3 times negative 2y is negative 6y. 3 times negative z is negative 3z equals 24. We're going to combine like terms where we can. So 5y negative y is negative 6y is negative y. Plus 31 minus 3z equals 24. I'm going to subtract 31. So negative y minus 3z equals 24 minus 31, which is negative 7. I'm still solving for y, so I'm going to add 3z, so negative y equals 3z minus 7, and since that's negative y, I'm just going to switch the signs. Now, we're almost done, I promise. We're going to plug this in. It's going to give us x now. We're going to plug it into 1. So for 1, we have x minus 2y minus z equals 8. So x minus 2y minus z equals 8. And the y we just found was negative 3z plus 7. So we have x equals, x plus 6z minus 14 minus z equals 8. And here we're going to solve for x. So we have x plus 5z equals 8. Minus 14 equals 8. I'm going to add 14. So 14 and 8, we get 22. Subtract 5z. So we have x equals 22 minus 5z. So our answer, I'm going to write it over here because I'm out of space. That's our answer. I'm not putting this on the test. It's just your homework. It's just 1 or 2 questions. Skip it if you have to. I get it. Alright, that was 8.1. I know that last one was a doozy, trust me. Alright, 8.6. Systems of non-linear equations. Alright, now we're solving systems of non-linear equations. So, to solve this system, you can use elimination, you can use substitution. There is a right way, but you can get to the answer regardless. It doesn't matter. So, I cannot use elimination, which is what we did up here in 8.1. I can't do it because do they have any matching variables? They don't. X squared, y squared, that's different than x times y. So I can't use elimination. I have to use substitution. So I need to solve for one variable in any equation. I'm looking at the top one. I can solve for something there because I just got to divide. Solve for x, solve for y, it doesn't matter. But you know what? I'm going to solve for y, and you'll see why in a minute. So to solve for y, divide by x, we get y equals 6x. Now I'm going to substitute this in for y. You see how there's nothing in front of y squared? That's actually why I solved for y. So we have 6x squared plus y squared equals 42, and that y is 6 over x. So we need to square it, and we get 6x squared plus 36 over x squared equals 42. I want to get rid of this ugly fraction, so I'm going to multiply by x squared. So I have 6x to the 4th plus 36 equals 42x squared. I'm going to equal this to 0. And I'm going to factor. But before we factor, let's see if they have anything in common. They do. 6 in common. I'm going to take it out. Alright, now I'm going to factor. So when you take out the GCF, it doesn't matter anymore. You can just get rid of it. So we have x squared, and then 6 and 1. So we have x squared minus 6 equals 0, x squared minus 1 equals 0. So we have x squared equals 6, square root, and we get x equals positive negative square root of 6. Same thing here. we have x squared equals 1 square root x equals positive negative 1. Now that's what x is. So we have 4 x's. We have x at negative square root of 6, x at positive square root of 6. We have x at negative 1 and x at positive 1. So you can plug these into any equation and then solve for y. I'm going to plug it into the bottom one. I know the top one looks easier, but it's actually way more difficult. So let's plug it into the top, or the bottom one. So the bottom equation, we have 6x squared plus y squared equals 42. We're going to plug this in. Alright, so negative square root of 6 squared. That sounds like stupid when you say that, right? Like negative square root of 6 squared. It's because they actually cancel each other out. So we have 6 times 6 plus y squared equals 42. 36 plus y squared equals 42. Subtract 36. So we get y squared equals 6. Square root it. And we get y equals positive negative square root of 6. So, you know how like we squared it right here? When you're squaring stuff and plugging it in, it's the same answer. It always works out that way. Alright, now for negative 1 and 1, since there is no square root, it's not crazy looking, I'm going to plug it into the top one. So we have xy equals 6, so negative 1 times y equals 6, that's negative y equals 6, so y equals negative 6. Gonna do the same thing with 1. See, I didn't square this time, it's not squared, so do not do that little trick. Okay, it's not squared, so we have to do it again. So we have 1 times y equals 6, so y equals 6. That means our solution Alright, next example. So I'm going to look at my two equations. They don't have any of the same variables. We have x squared, y squared, and x and y. Doesn't work, so I need to use substitution. So I need to solve for a variable in any equation. This is already solved for. I'm going to plug it in. I don't have to do any work. So I have 4x squared plus y squared equals 9, and the y we're plugging in this time is 2x plus 3. So we need to square that. When we square 2x plus 3 squared, when we square that, we get 4x squared plus 12x plus 9 equals 9. I'm going to combine like terms. I'm going to equal this to 0. Don't pay attention to that. And now I'm going to factor. So these have 4 and x in common, so I'm going to take it out. I'm going to set these to 0. So we have x equals 0 and x equals negative 3 over 2. You know how to solve for x. It's negative 3 over 2. So I need to plug these both in. I'm going to plug it into the top one because there's nothing really crazy going on there. Like, it's just like straightforward equation. it's a line, I can do that. So we have y equals 2 times x plus 3. So we have y equals 3. And then next we have our negative 3 over 2. So y equals 2 times negative 3 over 2 plus 3. The denominators cancel. So we have negative 3 plus 3, and we get 0. There's our solution. Alright, looking at our last one. Do you notice that they have the same variables finally? Finally, they have x squared, they have y squared, but they're not in the same order. So let's move this over to make it look the same. Since they have the same variables and they look the same, we can actually use the elimination method. So pick a variable, get rid of it. I'm going to get rid of y because they're already opposites. I just need to make them the same number. So I'm going to multiply the bottom by 3. So 3 times 2x squared is 6x squared. 3 times y squared is 3y squared, and 54 times 3 is 162. Those cancel, so we have 7x squared equals 175. Divide by 7, we get x squared equals 25. Square root, and we get x equals positive negative 5. So we have x equals negative 5 and x equals positive 5. You can plug it into any equation you want. So we need to solve for y, and we're squaring it. I'm going to use the bottom one. Y is just easier looking. They're positive. So I'm going to use the bottom one and plug it in. Do you notice we're squaring the x we're plugging in? So we will actually need to plug this in once because we're squaring it. So we have 2 times 25 plus y squared equals 54. So 50 plus y squared equals 54. Subtract 50, so we get y squared equals 4. Square root it, and we get y equals positive negative 2. All right, 8-7. Systems of inequalities. So if you need a refresher about systems of equations, graphing them, again, I have a video for this. So let's graph the inequality x squared plus y squared is less than 4. We're just going to treat this as if it was a normal equation. And then we'll get to what that little symbol, the inequality symbol, means. So this is a circle. How do I know it's a circle? It's x squared plus y squared. It's okay if you don't remember. That was way back in chapter 2. So the center, since there's no x squared plus something or y squared minus something or anything like that, the center is 0, 0. And remember the radius, we have to take the square root, and it's 2. So we're going to plot it. We have 0, 0. And then our radius is 2, so up 2, back to the center, left 2, back to the center, down 2, back to the center, right 2. Alright, all that symbol means is how do I connect the dots? And how do I shade? So it's okay if you don't want to go back to intermediate algebra and remember this, I'll just write it out for you. So since we have that inequality symbol, it's going to be a solid line. So we're going to connect the dots using a solid line. Now we need to shade. We shade because of the inequality symbol. So I like to do, this is a trick that I've come up with. So I read it to myself. So x squared and y squared are less than or equal to 4. Now, since it's less than, if I shade outside, isn't it getting greater? Like, because isn't it going out infinitely? But if I shade the inside, it's stuck there. It's stuck inside the circle. So I shade the inside. There we go. Alright, now we're going to do 2 and 1. So we have our first one. I'll do it in green. This is a quadratic, meaning it's a parabola. So since it's a parabola, we need y-intercept, vertex, and x-intercept. So the y-intercept, it's always that constant. So 0, -4. Our vertex, negative b over 2a. So we have -0 over 2 times a, which is 1. So that's just 0. And then we find the y of the vertex, so we're going to plug it in. Although, isn't this x equals 0? You notice we already have that, but anyways, let's talk more about that. So let's plug it in. We have y equals 0 squared minus 4, which is just -4. So the vertex is 0, -4. Now we find the x-intercept. So the x-intercept, we got a factor. So it's a difference of squares. So we get x is 2 and x is -2. Let's go ahead and plot this. So 0, -4, +2, -2, and it's going to be a solid line. So we connect the dots using a solid line. Now when we read it to ourselves, it says y is greater than x. So since it's greater than x, greater means up. So in this graph, I'm going to shade up. Okay. Now let's do our another one. Our other one, we have y is less than -x plus 2, so that's a line. So lines, we know how to graph. Our m is -1 over 1. Our y-intercept is 0, 2. So 0, 2, we go down 1, right 1, down 1, right 1, down 1, right 1. We can go the opposite way if we want. And since it has this symbol, it's dotted. So we're going to connect the dots using a dashed or dotted line. And then when we read it, it says y is less than x. So y is less than x is down. So we shade down. You see this little area right here where the blue and the purple meet? That's the solution. Why'd I do -2? I'm glad I caught that. Give me a second. Rewind. Let's do the blue one again. Positive 2. Then we go down one, right one, down one, right one, down one, right one. And it's dotted. Oh, I'm seriously about to throw my tablet. There we go. And less than, we do it down. There we go. This section right here, where they meet, pick anything from there and it works for both. Alright, I'm going to do a separate video and show you how to graph this on MyMathLab, because you know how tricky that can be sometimes. So just bear with me, I'll get to it. Yeah, I'm going to take that one out. Alright, don't worry about that one. And I'll send a different video for showing a demo on how to graph these, okay?